So hello and welcome everyone. Welcome to the problem of the day. My name is Jay Dalsaniya and today we are going to solve maximum sum in the configuration. So first of all, I would like to give you a target of 50 likes. Let's hit the target of 50 likes, and I would like to know what approaches you have in your mind. So do comment down your approaches in the comment section below. So without any delay, let's start the video. So the name of the question is maximum sum in the configuration, and let's try to understand what the problem statement is trying to say. You will be given an integer array of n size and you have to find the maximum value of the sum index multiplied by corresponding element for all the indexes from 0 till n minus 1. The only operation allowed is to rotate clockwise or anti-clockwise the array any number of times. So you have to find out the maximum sum of the configuration among all the configurations possible, and the configuration is rotated by anti-clockwise direction or clockwise direction any number of times. Okay, so let's try to understand with the first example that we have n equals to 4, 8, 3, 1 and 2 are the array elements, and let's try to explore this example. Okay, so here is the first example. You have to find out the sum of I into array of I for any configuration, and you have to take the maximum sum from all the configuration, and the configuration says rotate clockwise or anti-clockwise. Okay, so if you keep on trying out all the possibilities by rotating the array clockwise, then the anti-clockwise possibilities are also covered by clockwise rotation. So here I have taken the anti-clockwise rotation, that is rotating the array by one position on the left direction. So let's say the array is what 8, 3, 1 and 2, and this is the input array, and finding out this sum, this is 0 into 8, 1 into 3, 2 into 1 and 3 into 2. This is 6, this is 2 and this is 3, right? So 6 plus 3, 9, 10 and 11. So the sum comes out to be 11. Now if I rotate it by one position on the left hand side, 3 will be over here, 1 will be over here, 2 will be over here, and this 8 will come over here. So this is another configuration. So 0 into 3, 0, 1 into 1, 1, this is 4 plus this is what 24, 24 plus 4 plus 1, this is what 29. So here we got 29 as the sum for the second configuration. Now finding out the next configuration, 1 over here, 2 over here, 8 over here, and this 3 over here. So this will be what 1 into 2 is 2 plus 8 into 2 is 16 plus 3 3s are 9. 9 plus 2 is what 11 and 16 we get 27 over here. So for this configuration, the answer comes out to be what 27. Now let's see, and one more configuration is possible, right? So rotating by one position on the left hand side, this is the configuration. 1 into 8 is what 8, 3 2s are 6, and this is 3. So 6 plus 3 is 9, 9 plus 8 is what 17. So I got 17 is the answer for this last configuration. Now if I again rotate it, I'll be getting 8, 3, 1 and 2, and this is the input array. So these are the four possible configurations for the given array, and among all the possible sums, the maximum is 29. Hence, the output for the test case comes out to be 29. So that's what you have to find out, the maximum sum among all the possible configurations. So this is a pretty simple, understandable example and pretty understandable question. So I hope you got an idea what the question is trying to say and what we are supposed to find out as an answer. Okay, fine. So now let's try to discuss the first step of solution, that is brute force approach. What can you say about the brute force idea? So try to think what can be the brute force approach, because that's the critical step you will be finding out in every interview, starting with brute force, reaching out the optimal solution, right? So brute force idea, yes, exactly. So basically trying out all the configurations and finding the sum for each and every configuration and taking the maximum value, right? So this is the list of configuration. Now for the given array of size n, let's say n equals to what over here, it is equivalent to 4. How many configurations did you find? We have found 4 configurations including the initial one, right? So whatever is the number of n or the size of the array, that many configurations are possible. Okay, so we are sure about how many configurations will be there, n configuration, and in each configuration we can iterate over the entire array and find out the sum. So that would take us around n time for every sum that we are going to find out, right? So the overall approach that I can see in brute force is around n square. Okay, fine. And the space, what about the space? So I don't think any space is required to calculate the sum, just a variable will be required, some variable, keep on adding the values, right? So the space complexity in this can be taken as what? Constant. So the time complexity comes out to be what? N square, and the space complexity comes out to be order of 1. And if you have a look at the largest value of n, you will find out the n value can be as large as 10 to the power 5. Okay, fine. How many operations will be taking place in the worst case scenario? 10 to the power 5 multiplied by 2, 10 to the power 10 operations in worst case scenario. So what can you say? Will this approach be accepted or not? Absolutely not, right? In 1 second, we know 10 to the power 8 operations are acceptable. So 10 to the power 10 operation, definitely your approach will fail. Okay, fine. So this is our brute force approach. Now, as we know that this approach is going to fail, we need something optimal than that, right? So what can be the optimal idea about it? Let's try to analyze. So here, let's see optimal approach. So for the optimal approach, we need to observe everything like in each configuration, how we are able to find out the answer. So here, if you keep on finding out each configuration and if you calculate the sum from scratch, basically, if you calculate the entire sum, that is increasing over time. So what can I observe in the brute force idea? That where our time is consumed a lot. I can see while you calculate the sum, you have a time of order of n, right? The time required is order of n operations are done. And what about finding out all the configurations? So it is taking order of n. So now try to think which can be eliminated or which can be optimized. Can you find the answer by not finding out sum of every configuration? Is it possible to find out? No, the answer cannot be found before finding out sum of every configuration. Okay, fine. So at least I will be finding out all the configurations. But what about this sum? Can you reduce this sum? Yes, you can reduce the sum. How? Let's observe. So I will take this same example over here, which is given as an example number 1, and I will try to give you an analysis of the relations between the sum of configurations. Okay, so I'll start with the first configuration. I'll copy this entire thing because that's what we are going to do, right? So this is our initial configuration, and I'll name this configuration as what? Configuration number 0. So this is the naming given to configurations. Okay, okay, fine. Now for configuration 0, I can see the answer comes out to be 11. Okay, fine. But I need one more configuration to observe that with the help of configuration 1, how can I derive the answer or the sum for configuration number 1? Okay. So let's try to see what will be your configuration number 1, rotating by one position on the left hand side, right? So I'll be having 3, 1, 2 and 8. Now what will be the sum over here? 0 into 3, right? 1 into 1 plus what? 2 into 2 plus what? 3 into 8, right? What is the sum over here? I will be getting 1 ones are 1. This is what? 4, and this is what? 24. I get 24 plus 4 plus 1, that is what? 29. Okay, fine. Now I have sum of configuration number 0 and configuration number 1. Okay, so how can I derive optimally by not finding out the entire sum and iterating or having operations n number of times? How effectively can I utilize the previous configuration sum to get the current configuration sum? If you observe the positions. Okay, so this 3, how many appearances of 3 do we have here? I have one appearance in the sum for configuration 0. Here, how many appearances of 1 do we have? So this is the element, and 1 has how many appearances? Only 2 appearances. And how many appearances 2 has? 2 has only 3 appearances over here in the configuration number 0. Now let's analyze the same element over here. 0 into 3. How many appearances of 3? 0. Here 1. Here 2. And here how many appearances of 8? I have 3 appearances. And here how many appearances of 8? 0 appearances. So you can observe for this element, basically you can see their appearances are reduced by 1. Their 1 appearance has been reduced. So can I write down something like this? 11 is the previous sum minus sum of 3 appearing ones, sum of like 1 appearing and 2 is appearing, right? Here you can observe 3 is extra. Now in this configuration, no appearance of 3. Here 2 appearances of 1, but here we have only 1 appearance. So here 2 appearances, I mean 3 appearances of 2. So I'll be having only 2 appearances. So I need to reduce 1 appearances of these 3 elements, starting from index number 1 till last index. And I will call this element whose appearances are increasing drastically as exceptional element. The element at the first position for the previous configuration or every configuration, I'll call it as what? Exceptional element. So we need to handle it differently. But I can write down as 11 minus 3 plus 1 plus 2. Okay. So this thing can be written in a different manner. How can you write down this thing? So I'll take the sum of entire array. So that would be what? 8 plus 3 plus 1 plus 2. This is what? This is around 14. 8 plus 3 is what? 11, 12, 13 and 14. Okay, fine. So can I say what is our exceptional element over here? So exceptional element of previous configuration is what? 8. Okay, fine. So can I say instead of writing 3 plus 1 plus 2, can I write down in this manner? I have the sum of all the elements, that is 8 plus 3 plus 1 plus 2. And from that sum, if I subtract the exceptional element, for configuration 1, the exceptional element is the element at 0th index in the previous configuration. 8 is the exceptional element for config 1. Can I subtract this 8 from it? So doesn't it mean that I'm subtracting 8 from this, right? This is same. So I can write down sum minus the exceptional element. So what is sum? Sum is what? 14. I'll say 14 minus exceptional element is what? 8. Okay. So just a summary. So what are we doing? So if my configuration is what? I represents my configuration number. Then exceptional element is what? Exceptional element is what? Array of I minus 1. See, here the configuration number is what? 1. And exceptional number is what? Previous configurations, what? 0th index element. That is 8 is my configuration number. Okay, fine. And how it come array of I minus 1? So you take the element from the input array at I minus 1th index. Okay, fine. So 14 minus 8. Okay, so what do we have? But I need to add the exceptional element, right? Exceptional element is multiplied by what? It is multiplied by n minus 1. N minus 1 into exceptional element is what? 8. So to this sum, basically I need to add n minus 1. Exceptional element is 8 multiplied by n minus 1 because its occurrence is now n minus 1 times. So I'll be having 11 minus what? 14 minus 8 is what? It is minus 6 plus what is this? 8 into 3. 8 threes are what? 24 and 11 plus 6. What I will be having? 6 plus 1, 17. 17 plus 24. Okay. So we made a little mistake. This is not minus 6. This is 6. So 11 minus 6. What do we have? It is what? 5. 5 plus 24. I have 29 and this is what we get. Right. So let's observe with one more configuration. Okay. So you might be wondering, okay, how is this happening? So bear with me just a minute. So I'll explain with one more configuration. Now the second configuration rotated by one position on the left hand side. This is configuration number 2 and the rotated array will be what? 1, 2, 8 and 3. So this is what? 0 into 1. Okay, fine. Plus what? 1 into 2 plus what? 2 into 8 plus what? 3 into 3. So let's observe the analysis. So exceptional element, I will handle it differently. So let's see how many appearances of 1? Only 1. How many appearances of 2? 2. How many appearances of 8? 3. Okay, fine. Here, how many appearances of 1? I have only 0 appearance. How many appearances of 2? Only 1. How many appearances of 8? 2 appearances. So, from index number 1 till last index, all the elements appearances are reduced by 1. So, from 29, what should I subtract? From 29, I should subtract what? Sum is what? 14. 14 minus exceptional element of the previous configuration. For configuration 2, exceptional element is what? The previous element, that is 3. 0 is 3 is our exception element for configuration number 2. Plus what should I add? I should add the appearances of exceptional element. So exceptional element is what? 3 multiplied by n minus 1. Right? You can observe its appearances is increasing. It is what now? 3 plus 3 plus 3. So this is what? 3 into 3. So I'll be having 29 minus 14 minus 3 is what? 11 plus 9. So 29 minus 11, what do we have here? We have 8 and what is this? 11. I mean 2 minus 1 is 1 and this is what? 27 is what, right? 16 plus 1, 17 and 27. So here I got this sum as what? 27. If you want to verify, this is what? 0. This is what? 2. This is what? 16. And this is what? 9. 9 plus 2 is what? 11. 11 plus 16 is what? 27. Right? So from this, what I can write down? I can write down a general formula. Okay, fine. That would be very much helpful, right? So let's say for ith configuration, I'll need the sum of the previous configuration. Okay. So I can say for the ith configuration, the sum for the ith configuration is what? Previous configuration sum minus the elements whose appearance is reducing by 1. So for that I will take sum of the array minus exceptional element. Exceptional element is what? Array of I minus 1. To this, what should I add? I should add the appearances of exceptional element. So exceptional element is what? Array of I minus 1, and its frequency is multiplied by what? N minus 1. So this is how I can find the sum for the ith configuration, but we need the answer or sum for the I minus 1th configuration, right? So from this, you can find out for any given value of n, you can find out the sum for any configuration. And there are going to be n number of configurations. So now here you can observe we optimized the summation part, right? For ith configuration, we were using an iteration of n to find out the sum. But now we simply have a formula, sum of the ith configuration is this, right? So now let's summarize the algorithm, that what is our algorithm. So algorithm says, first of all, what do you need? I need sum of the array. Okay, fine. And where will I store this sum of the array? Let's say I have created a variable called as sum. Okay, now what I need? I need an initialization configuration. That means for starting, I need the answer for 0th configuration, and that is your input array. Okay, so 0th configuration answer, 0th configuration sum. So what is the 0th configuration sum? I will call it as previous, right? Okay, fine. And what else is required? I need an answer variable to store our answer, right? To store our maximum sum among all the configuration. So what should I initialize this answer? So how many configurations are there? N configurations. And it starts from 0 till n minus 1. So I will initialize this answer with 0th configuration sum, that is previous variable. Now you can start solving for the configuration starting from 1 to what? N minus 1. So I'll say I represents the configuration number and I is lesser than n. Okay. Now for this current configuration, I'll call the sum for current configuration is temp. What is temp? I'll copy this entire formula, right? So I'll say temp basically means the sum for current configuration is what? Previous configuration minus sum of the array minus array of I minus 1 plus the exceptional element appearances. Okay, fine. Then now what to do? Now compare with the answer, obviously, if you want the answer. So I will write down, I'll update the answer if required. Answer is what? Maximum of answer and current configuration sum, that is our temp. Okay, fine. And what we need to do, we need to update the previous, because for the second configuration, previous will be sum of first configuration, right? So here, previous will be updated as what? Previous will be now updated as sum, because we will be utilizing it further, right? And at the end of the algorithm says just print the answer or return the answer, and that's it. Now you can see the analysis, right? The sum that I was utilizing an iteration to find this sum, now it is taking constant amount of time. And if you analyze the time complexity here, to find the sum of the array, it will take n iterations, and for 0th configuration n iterations. And this part is also iterating n number of times. So overall time comes out to be what? Time complexity comes out to be order of n plus n. And I can say it as order of n, and the space complexity over here comes out to be constant, right? Apart from variables, what are you using? Nothing. That depends upon the size of the array. Okay, so this is the entire algorithm for our maximum sum in the configuration problem. Okay, it was pretty easy and just an observation was required. So with the help of this algorithm, you can code your solution in any languages, right? So take the reference of this algorithm, but here in this video I'll be coding in so-called Java programming, right? So that's my primary language. Okay, so let's start the implementation. So I'll be going step by step, right? So first of all, what things are required? I need sum of the array. Okay, fine. And 0th configuration sum is also required. Okay, so for that I need a simple iteration, I equals to 0, I is less than I plus plus. Okay, fine. Now sum of the array is what? I'll need a variable, right? So let's declare a variable. So you might be wondering why long? Because here you can observe long is the return type. Okay, fine. So does it mean long for all the variables? No. Observe the constraints. You can observe if you multiply index with element, maximum index will be 10 to the power 5 minus 1. Let's take it as 10 to the power 5. multiplied with 10 to the power 6, answer will be 10 to the power 11, and that lies in what? Long data type, right? So I'll be taking sum of the array is what? Sum of the array as long I'll be taking, and zeroth configuration sum I'll be calling it as previous, and that is also what? Long data type. So previous is what? It is the addition of the product of element and its index. And what is the sum of the array? It is simply addition of all the elements, right? So array of I. So now this is it, right? But I need the answer variable. So I'll say long answer is what? I'll initialize with the zeroth configuration, right? Zeroth configuration is what? Previous variable. Okay, fine. Now find answer for all the remaining configurations. So I'll start from configuration number 1 till I will be going till n minus 1th configuration. Okay, fine. Now for the current configuration, the sum will be stored inside temp. And what was the formula? Previous configuration minus sum of elements whose appearances are reducing by 1. So that would be sum of the array minus what? The exceptional element. Exceptional element is what? Array of I. No, array of I minus 1. Okay, fine. Plus what I need to do? I need to add what? Array of I, basically the exceptional element, and it is array of I minus 1. Okay, do not forget. Multiplied by what? I? No, n minus 1, because its appearance is now n minus 1. See, one more typecasting is required over here. So we mentioned long data type, right? So array of I, it can be as large as 10 to the power 6, and n minus 1 can be as large as 10 to the power 5. So this will be an integer multiplication, because the data type over here is also integer. Let me change this a to arr. So I need a typecasting, so I'll typecast this into long. And here also, for safety, I'll do it both the ways. And similarly here also we forgot, so I'll be doing it over here as well. Okay, fine. And that's pretty much. Now we have the answer for our current configuration, that is what? Previous minus sum of the array minus exceptional element plus exceptional elements occurrence is n minus 1 time. Okay, fine. Now update the answer. Answer is what? Answer, if it is greater than 10, then let it be answer only. Okay, else what to do? Else assign temp, because it is a greater one, right? And then what you need to do? You need to update the previous, right? So previous now will become your temp for current configuration, will be taken as previous for upcoming configurations, right? So many configuration, right? So let's return the answer, and this is my answer. Okay, fine. So let's try to compile run first of all. Okay, so working perfectly fine for this 172, and let's try to submit it. And we can see that the problem has been successfully submitted, and the time complexity is order of n. We are already analyzed. See here, it takes order of n iterations, and here also it takes n iterations. So linear time complexity, that is order of n, and the space, no, nothing extra has been used, right? So space is constant. So that was it for in this video, and I hope you really enjoyed this video. And if you really enjoyed this video, then do hit the like button and share your views on this solution, because it can be done in a different manner as well. You can try out the uh, right combinations as well, right? So try that approach on your own, and do hit the like button, and remember the target is like, let's say 50 likes in this video. So thank you for watching this video. I will be meeting in the next video. Till then, bye bye.